Hello and welcome to this first lecture of the new section on monitoring and maintenance of the AI solution that has been built, and we will take a look at that in this course. So the purpose of this section is to help you learn how to maintain and monitor the deployed model that can help you become a successful AI engineer. And here we will talk about how do you monitor and deploy these models to ensure they continue to perform well over a period of time. And then you need to also update and retrain them as needed to adapt to changing conditions or requirements. So how do you think you can monitor and maintain the deployed models? See, obviously this is essential in monitoring the deployed model to ensure that they continue to perform well over time and also to know when the updates and retraining may be necessary to adapt to the changing conditions or requirement because the data will change, the customer requirements will change, the environment keeps changing. So how can you monitor deployed models effectively? Let's take a look at the steps that you can take. So first is to determine the key performance metrics for evaluating performance model that you have. And it could be any of these that you see here, including accuracy, precision, recall, F1 score, area under ROC curve, CV error, blue score, NEL for NLP, RAND index, mutual information index, R square, all that we talked about. You can go back and pick from there what are the right key performance metrics that you need to do. Then what you need to do is to define threshold or benchmarks for each of these performance indicators that will reflect acceptable performance levels. That's a kind of target for these levels that you must achieve. If your accuracy, you might say, I want to achieve a 99.5% accuracy, or I want to achieve 99.9% accuracy. And that will be based on your business requirements and expectations. So you would work with your business partners to figure out what those expectations are. Then what you need to do is to implement real-time monitoring of the model predictions and performance matrices in the production environment, real life. And then there you need to monitor prediction latency. What is your prediction latency? What is the throughput? What are the error rates and the distribution of the predictions over a period of time? Also, then you need to set up alerts and notifications to trigger when performance matrices deviate significantly from expected values. Once you have that set up, then you need to log all model predictions, input data and metadata associated with the model inference request and maintain an audit trail of model versions, of configurations and updates. So it's a lot of data collecting task that you need to do. Then you need to check about monitor the data drifts. That's one of the important one of the things that can happen that can throw your model out of gear is to monitor the data drift or changes in the distribution of input data over a period of time. And there you need to use compare the incoming data to historical data and detect deviations that may impact the model performance. And you can use statistical tests, visualization techniques, and drift detection algorithms to identify the data drift. Right. So what do we do in the next one? So we will dig deep into how to compare and detect data drift using these techniques of statistical tests, visualization techniques, and drift detection mechanisms in the beginning in the next lecture. So thank you so much for watching this first monitoring and maintenance lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question and also download the PDF file to take a look at anything that you need to.